Okay, for today's lesson, we'll be going through the properties of matter, in which how can materials be classified. So these are some of the items or the learning objectives that you have to complete. Number one, you must be able to describe the materials in terms of physical properties such as hardness, elasticity, solubility, density, boiling melting point, electrical and thermal conductivity. Do note that it is crucial for you to use these words to describe the physical properties. On top of that, not only do you have to understand what are the physical properties certain materials have, you have to be able to use these properties to explain its functions or why do we use it to make the material or the item that we want. Next, we also have to compare the materials in terms of physical properties. The reason for being able to compare is so that we can actually choose the appropriate or the best materials to make the particular item that we want. And definitely, there are some ways to classify materials, be it from metals and non-metals, and examples of non-metal would be your ceramic, plastics, and fibers. And all this will be actually further explained in the subsequent lesson. Now, all these slides are actually copyrighted to Star Publishing Private Limited, and it is one of the textbooks that you should be using for your normal tech science lessons. Okay, without further ado, let's begin. Now, for physical properties of matter, like what we have studied previously, is that it is mainly made up of things or amount of particles, and that it usually occupies space. So metals can also be used to make an object which is called the material. So the material is basically how you can actually classify or name the item that you make the matter, apart from the different states of solid, liquid, and gas. And then all these materials can be further separated or categorized based on their physical properties of an object. So as we can see, the rope, the ceramic tiles, the oil, the bottle of oil, the aluminum food carrier, all these are actually items. But what are some of the materials that you can use? Like for example, the floor tile, you can use the ceramic. Bottle of the oil, you can use plastic. Aluminum food carrier, you can use maybe metal or aluminium for it, and so on and so forth. Now, what are some of the physical properties of material? Every material will be able to have its own physical properties, and that every material can have a range or a variety of physical properties. It doesn't mean that one material will only have one physical properties, but these physical properties will allow us or to help us to understand how the material can be used to better can be used for us to better use it properly. So some examples of physical properties are hardness, electricity, solubility, density, boiling and melting points, electrical conductivity, and thermal conductivity. Now all these, there is quite a lot for you to remember, there is a lot for you to understand, but what we can do is basically the following. So we need to actually understand what is the difference between all these physical property rather than classifying it all the same. So what is hardness? Hardness is the ability to withstand scratches. The highlighted area is actually the keywords that you should be using for your examinations. Now, ability to withstand scratches, meaning that if let's say you use another material to scratch it or to move against the surface along of the material, is there a mark? Okay, for example, when you when you use your keys and you scratch it along, you pull it along your handphone screen, do you see any marks along it? If there is, then most probably the material that is used to move along the other surface is actually harder. For example, if we use diamond, we can actually use it to actually scratch other materials, as diamond is one of the hardest material in the world. So a harder material can be used to scratch or to cut softer material. So in this case, when we look at diamond is already so hard. So how are you able to scratch another diamond? Definitely you will need to consider the other diamond to be of a higher or harder physical property, in that sense that it has to have a greater, harder property to scratch the diamond. What about elasticity? Elasticity is the ability of a material to return to its original length or shape after stretching or bending. Now, do take note that this means that when you pull it, it should be able to retain close to its shape without breaking. For example, rubber band. When you pull, it is able to return back to its original length. Now, in this case, you could, if you overpull, some of you may say that if you overpull the rubber band, it snaps. Then you could say that the rubber band has a lower elasticity as compared to another material. So another example is when you make noodles. You pull a very long dough and it didn't scratch. Or maybe roti prata, when you actually roll it and then you stretch it out, it didn't stretch. Basically, it shows you that that particular material has great elasticity. But when you use another item, let's say paper, you try to pull the paper, it breaks, it tears easily. That would actually show you that paper has a very low elasticity, in which it is like totally non-existent. So one common elastic material is rubber. Now, the third property is solubility. So solubility of a metal is measured by the maximum amount a substance can dissolve in a given amount of liquid at a given temperature. Now, let's break down all these things into smaller bite-sized understanding. So maximum amount of a substance, usually it is actually talking about the weight of the solid that you use. Given amount of liquid, which is the second one, is basically the volume of liquid used. In this case, it can be most of the time it's actually water, it can be a solvent, etc. At a given temperature is the third point. Why do we say at a given temperature? Because temperature can influence the solubility of the material. For example, let's say you want to make a Milo drink. When you use solid particles and then you add, like the Milo powder, when you add it with cold water as compared to maybe you use the same Milo powder and you add it to hot water, you realize that it is able to dissolve at different rate. This will show you that at different temperature, it could actually bring about different solubility. So where you could ask is the temperature. It's the temperature of the water. So that could actually affect the solubility. That is why solubility is defined by these three main factors that can actually influence its physical property. Number one, the maximum amount of a substance. Usually it's the maximum weight of solids. Now in this case, when you add too much of the solid, you realize that some of the solids are not actually dissolved. That would show that the item has already been so concentrated to the point that the solubility cannot be further increased in that sense. How to go about dissolving those excess solids? You can actually add more of the liquid. So that's why it can actually dissolve in a given amount of liquid, which is the volume of the liquid, which is the second criteria, as having more water or more of the liquid could actually increase the solubility of the substance or the mixture at any given temperature. So this is illustrated at the following point, where 35 grams of salt can dissolve in 100 cm³ of water at room temperature. But sometimes if you use a different material, now we are comparing salt with respect to copper sulfate, you realize that a different weight, one is 35 grams, the other is 20 grams, they can dissolve the same volume of water at the same temperature. Now what this actually shows you is that the solubility between salt and copper 2 sulfate is actually different. Okay. Third, the next one is, what is density? So density is the mass per unit volume of a substance. Now this definition is very, very important I would strongly suggest you to memorize this particular definition. And through the definition, it's actually a repeat of the formula. So what do we mean by mass per unit volume? You treat this per unit volume as a divide sign. So in this case, density is the mass divided by the volume. This word is, you can treat it as an equal sign. So if I were to rewrite it, density equals to mass divided by volume. Now, what are some of the units for this? Is that grams, you can put it in G, which is the SI unit. Volume will be in cm cube, and density is actually grams per cm cube. Now this slash is like a slanted divide sign, so that is another way you could help you to remember what it is, what's the units for density. Some of you may be more familiar with the triangle, in which density is at the top, let me retract that statement. Mass is at the top, followed by density, then volume. Okay. Now so what does this density means? Is that a material that has greater density will sink. Okay. Greater density, it will sink, while a material that has less density will float. This density is influenced by mass and volume, and in this case, a lot of students would always say, why does let's say when you throw a iron metal into the ocean, why does it sink? Some common answers that we have seen is that because it has a greater density, full stop. Now it is not a complete answer. How should you phrase your answer is that when a very heavy item is dropped, okay, like an iron metal piece is dropped into the ocean, into the swimming pool, you should be saying that the iron material has a greater density as compared to water. If the swimming pool is filled with water, and therefore the material would sink. This is quite crucial. Now the second thing is, how do we explain density? Always refer it back to mass and volume. So having a greater density is usually influenced by either your mass or influenced by your volume. So we can show this chart, which is the greater the mass, if you increase mass, this would bring your density to be higher, assuming that volume is unchanged. Okay. The other way you can also see is that when the volume is greater, density will become smaller. And when density, and this is assuming that mass is unchanged. Now this is actually a very nice way to actually explain your answer. Now will the question ever ask if mass increase and volume increase, what will influence the density? Not likely. At your level, at this current stage in our lesson, just take note that we usually try to test only if one of such of the factors change, then how it influences the density. So whenever you are asked a density question, some keywords that we are looking for are, like for example, mass, volume, and definitely density. And when we look at density, we are looking at something comparing to something, resulting in whether will it sink or float. So in density questions, please make sure that you have these 4 main points to gain your maximum amount of marks. Now, the next question is, do we have to memorize all of these numbers? The answer is no, but one important one that you may want to remember would be water. And it's easier to remember because it is 1. Now what this means is that these values here, do you see that they are less than 1? And if they are less than 1, it shows that they are having a density that is lesser than water. So if I were to write here, density lesser than water. So what does this mean? It means that it would actually float above water. On the other hand, if we look at the items here, we can see that this shows that density is higher than water. So this would show that it would actually sink in water. Okay, so this is some of the things you want to take note of. Do not worry, in exam we will not test you all these numbers, but it is important that you need to have the ability in which to read the numbers if, let's say, all these data are given to you, and not just to read but to also explain and to interpret what will happen. Will it sink or will it float? What's in terms of the density, is it higher or lower? So in terms of phrasing your answer, first step is to compare the density. The second way is to tell it will it float or sink with respect to the item that is used as the benchmark. Next is boiling and melting point. So in our previous lesson, we also learned that melting and boiling point in a pure substance is fixed. This could be seen when there is no change in the values when it changes its state. So for boiling, it's actually from the liquid state change to the gaseous state. And for melting, it will be from the solid state change into the liquid state. So boiling is the temperature at which a substance changes in terms of states, and melting point is the temperature at which a substance changes in state. Now a lot of you have a common mistake, which is you always write, when the question asks for temperature, you always give either 100 degrees Celsius or 0 degrees Celsius. Now do take note that these values only applies to pure water. It is not the boiling point or melting point of all substances. So be very careful when the question asks what is the boiling point. If they ask what is the boiling point, do read the question carefully and see what substance is given to you. Only if the boiling point, if the question asks what is the boiling point of pure water, then it's 100 degrees Celsius. If the question asks for what is the melting point of pure ice, it is 0 degrees Celsius. Another fun fact to know is that melting point of ice is actually the same as the freezing point of ice. So this can be done interchangeably, and that for boiling point and melting point, both actually absorbs heat for the ice. Again, you will not be required to actually memorize all these values, but one kind of question that can be asked is they will actually tell you what are the states of the particular substance at a particular temperature. How do you go about doing it? First step in any exam, if let's say this is an exam question, always write it in terms of solid, liquid and gas. So for melting point is from solid then to liquid. Always write it in this range, the 2N. And boiling point is from liquid to gas. So what does this mean? Okay, this means that any temperature that is within this range here, it's a solid. Any temperature that is between 0 to 100, minus 117 to 78, minus 210 to minus 196, and minus 218 to minus 183. These are all liquid, and anything above these temperatures here, it's a gas for the respective material. So this is another one to take note. Some questions they like to trick you in the form of what's the range. So if you look at a number line, let's say 0 is the base mark. The more positive the number is, so 100, maybe 200, maybe 300. This shows that the temperature is greater. But the thing, it differs because you can see when you go to negative, the numbers changes. So do take note that minus 300 is actually lower. Minus 300 is lower, or you can say a smaller value than minus 200. Whereas the number 300, which is positive, is higher than the number 200. So do take note of all these different types, and of course all these are your temperature in this case. Okay, so let's do a simple exercise. If let's say that the temperature for at that 24 degrees Celsius, what is the state? So in exam, you just identify, is 24 degrees Celsius below 0 degrees Celsius? Is it between 0 to 100, or is it above 100 for water? So in this case, it is actually water, so you just put an X. For alcohol, in terms of minus 117 to 78, 24 degrees Celsius is also in the middle. 24 degrees Celsius, you could see that there's a change for nitrogen as well as oxygen. This means that water is in a liquid state at 24 degrees Celsius, and this is similar for alcohol. For nitrogen and oxygen, they are actually in the gaseous state. Is that clear? Now you can do some practice. You can pause the video and do some practice. Find out what is the melting and what is the state of metal for the items at maybe negative 300 degrees Celsius, or you can say at 200 degrees Celsius. So again, the practice comes into play. At minus 300, it's here, 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 and here. This shows that it is at minus 300, all are solids. If you are looking at 200 degrees Celsius, it'll be here, 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 and they are all gas at 200 degrees Celsius. So these are some common questions that can be tested in any form of examinations. Next, we look into the next physical property, which is electrical conductivity. Electrical conductivity of a material is the measure of the material's ability to conduct electricity, meaning the higher the electrical conductivity, the higher it can conduct electricity. And how do we measure electricity? One way to measure is using current. So what you will see is that the current will be higher as you have a greater electrical conductivity. So some of the items that can be used is, for example, if you want to pass electricity around the classroom, like to switch on your light and what's not. So the wires, they tend to be made of metals, as metals are examples of good conductor of electricity, as they allow electricity to pass through them easily. So we can usually see how electrical conductivity for these substances, for plastic, glass, rubber, they have very poor conductor of electricity, and most of the time we call these items insulators. So insulators are materials that have very poor electrical conductivity, meaning very little to no electricity can pass through. Copper, tungsten, they are materials with good electrical conductivity, so we call them conductors of electricity. Good conductors of electricity, and that they are able to pass through electricity, can pass through easily. Okay, next, thermal conductivity. The meaning of conductivity, similarly, if you have seen, is actually can pass through easily. So when they use the word electrical, it means electricity can pass through easily. When they use the word thermal, it means that heat can pass through easily. And thermal conductivity is the material thermal conductivity of a material is a measure of the material's ability to conduct heat. So for example, in this experiment, you would see that wax on the copper rod will melt first. This would show that copper is a better conductor of heat. Why? Because heat can pass through easily or can travel easily within the copper material. Now another thing is, do you feel hot very fast? Not really. Why? Because we are surrounded by air, and the air is actually a poor thermal conductivity. So if air is actually a good conductor of thermal, if air is a good thermal, has a good is a good thermal conductor, we will feel very hot very fast and very easily. So in terms of highest to lowest thermal conductivity, these are the items, and what you can see, a general trend is that all these are actually metals, and you are moving towards non-metals. So a gas is a non-metal, whereas gold, brass, all these are metal. So we can see that for thermal conductivity, the more metal it is, the greater the thermal conductivity. The more it's a non-metal, the lower the thermal conductivity. It would be good if you are able to remember the ranking, but it is not so important. What you need to know is that for metals, they tend to have a higher thermal conductivity as compared to non-metals. Some examples of metals are like stainless steel, silver tray, brass, aluminium, gold, copper. Now, do take note of the material rather than the item. So the materials are highlighted in yellow, and these are actually the material for metals. And one of the common ways to classify things is whether is it metallic or non-metallic. Okay, non-metallic materials are like your wood, your cloth, which is your fiber, ceramic tiles, plastic, and rubber gloves. So one thing, like for tiles, we tend to use ceramic because they are very low in thermal conductivity. That's why when you actually walk around your house, you don't feel very hot. It's actually quite cooling. Wooden utensils are another way when you do cooking, because if it's something so hot and you use a metal fork or spoon, you may actually burn your hand when you are drinking a hot soup. So some utensils can be made of wooden. So non-metals can also be classified into ceramic, plastic, fibers, wood, and glasses, and this is due to its property, such as surface texture, density, as compared to the density of water. So for all this, you can actually read up, you can pause the video and read up on how the different materials with the purpose that it can be, and why do we actually use such materials to create certain products. Okay, for non-metal, it can also be classified into ceramic, plastic, fiber, wood, and glass, which are the same as the top. But do take note that there are other physical properties like boiling and melting point, thermal conductivity, and electrical conductivity. So all these are examples. Next is properties and uses. So the choice of the material to make something really depends on its properties as shown above. So using the wrong material due to the wrong property could lead to other drastic consequences. For example, if the handle of the pot is actually made of metal, it could actually burn your hand because metals are good thermal conductivity. So what you will want is to use maybe plastic to replace as handle, so that when the person holds onto a boiling hot pot, they will not get burnt. So these are some other examples of why we would actually use these materials to actually construct all these products. And that is the end of this particular section.